Namaste. In this video, we are going to look at a question from GATE 2021 Metallurgy paper. For this question, you can use Mechanical Behavior of Materials by Dr. S. Sankaran as a reference video. The question is as follows. An infinite metal plate has a central through thickness crack of length 80 by pi mm. The maximum applied stress in megapascal that the plate can sustain in mode 1 is given as dash. And we are here to assume about it is a linear elastic fracture mechanics is valid and the fracture toughness is also given. Linear elastic fracture mechanics assumes a material to be isotropic and linear elastic, and the stress field near crack tip is calculated using the theory of elasticity, where when the stresses near the crack tip exceeds the material fracture toughness, cracks is about to grow. So what is mode 1 fracture? Mode 1 fracture is that when the stresses are being applied is perpendicular to the crack surface. As you can see from this picture, the stresses are being applied where the crack tip is perpendicular to the applied stress. In the question, it is given as central through crack, which means if the given crack is mentioned as surface crack, then we can take the given length directly and use it. As it is given as a central crack, we have to take half the length of the crack and use it for the question. So the central crack is given as 80 by pi mm. So half of the length is 40 by pi mm. The fracture toughness is given as 20 megapascal root mm, which means it is 20 into 10 to the power of 6 pascal root mm. As this is root meter. As this is given in the terms of meter, here we have to convert it into meter also, because all the units has to be necessarily same. So 40 into 10 to the power of minus 3 meters. The fracture toughness formula is given as maximum applied stress into square root of crack length. So the fracture toughness is given, the crack length is given, and we have to find the maximum applied stress, which is very easy as we have to directly include the values. Fracture toughness is 20 into 10 to the power of 6. This is what we need to find, into pi into 40 by pi into 10 to the power of minus 3. Pi get cancelled, and this is 20 into 10 power 6. This can be taken as square root of 40 into 10 power minus 3 is what we need to find. So this is 20 into 10 power 6 divided by 2 into 10 to the power of minus 2. So sigma max is 10 into 10 to the power of 6 into 10. So it is 100 megapascal. So the maximum applied stress is 100 megapascal.